Hello everyone, my name is SantosAlthoff. I am a PhD student of the Informatics Department from University of Brasilia. My advisor is Professor Mylene Farias, and today I will present the work entitled Impact of Alignment Edits on Quality of Experience when Watching 360-degree Edited Videos. This presentation is split into four parts. First, the research conceptual background. Second, a description of the motivation and challenges addressed in this work. Third, the user experiment configuration. And finally, the result and analysis from the gathered data. 360-degree videos are the main format of immersive multimedia since it is component of a variety of virtual reality applications. A specific process of 3D graphical renderization enables the user to interact with the visual environment. The rendering process of a 360-degree video starts by mapping each frame into a sphere. From the visual sphere, a perspective projection provides a spatial subsampling of the sphere that is called viewport. The viewport can be defined by user head position by embedding it with a camera positioned in the center of a graphical visual sphere. This enables cameras rendering controlled by head positioning, where users experience immersive environment very distinct than that of traditional videos. Quality of experience for multimedia systems and applications is a wide concept and important for our work. Patrick Lecale and others define quality of experience as the degree of delight or annoyance of the user of an application or service. It results from the fulfillment of his or her expectation with respect of the utility and or enjoyment of the application or service in the light of the user personality and current state. The volume of data transmitted in the consumption of 360-degree video are around 3 times that of a 2D video. This poses significant challenges for its efficient transmission via the Internet. For instance, within an entry-level specification, a video with 2K resolution rendered in the HMD with 30 frames per second demands a bitrate transmission of 64 megabits per second for transmitting a 8K full 360 data. For ultimate resolution levels, with pixel density next to that of a human eye, it is necessary plus than 3 gigabits per second. For comparison, average data rates of 5G are of hundreds of megabits per second. The dynamic of a 360-degree scene are highlighted by positioning and motion of region of interests. When multiple regions of interest are placed in the same scene, we have a shared attention environment. A stressful sensation of missing important events can be activated in such shared attention environment. This psychological phenomena is referenced as the fear of missing out. Moreover, if some scene element captures user attention in the wrong way expected by filmmakers, viewers will miss important events to understand the story or to enjoy the best from the content. With such challenges, adaptive functions in the playback of videos that enables optimizations was proposed with success in the literature. In this study, we are interested in examining the alignment edits as adaptive strategies. Alignment edits are those specific video transitions that can be applied to align user field of view with a region of interest. Two kinds of alignment edits are considered in this work: the instant alignment and gradual alignment. Both alignments follow strategies studied in previous works. The instant edit was based on the work of Dumbra of 2018, in which the alignment of the user's viewport and the ROI is done between 2 frames of the video, rotating the visual sphere only in the yaw direction. This strategy was successfully implemented for adaptive streaming optimization. However, it may break the sense of presence and the original study only considered two contents for the user study. The gradual edit was based on the work of Farmani of 2020, where the rotation is combined with a fade-in-out effect to reduce cybersickness by simulating the blink of the eyes. In the conducted user study, this mechanism reduced significantly the cybersickness, but it was tested only for VR gaming contests. Applying optimal edit can keep the quality of experience level while enabling optimization capabilities unfeasible for the case of free view in 360-degree videos. In order to achieve that for real viewers, user studies for systematical parameter testing is demanding. How alignment edits influence subjective quality of experience? From this wide question, our work focused on studying the impact of content and edit on quality of experience scores, gradual edits acceptability in terms of comfort and presence, and how the alignment of content and viewers impact user behavior after edit. To answer those questions, the performed experiment counted with 6 videos and 6 edit types corresponding to a total of 36 conditions. Sphere alignment rotation is done only in horizontal direction and is defined as the angle between the assumed viewer direction and the region of interest. For instance, for the video park, theta r was equal 180 degrees. All edits was applied manually using a video editing software with special plugins for 360-degree videos. Instant alignment occurs at timestamp of 15 seconds. Regarding gradual edits, they had a duration of 2 seconds with the fade effect starting 500 milliseconds after the rotation. Since angular displacement is the same for a given video, to be able to control angular speed of the edit rotation, we had to apply an instant offset in the black frame. To select content, we considered the scene dynamic of the video, as well as a presence of two obvious regions of interest that could be used to apply the alignment edit. 3 types of scene dynamic was considered from videos collected in available datasets. The videos Amizade and Park was provided by producers of Brasilia and was also part of a dataset recently submitted to the conference MMCs. The design of the experiment is within subjects, where each participant watched all conditions. After the stimulus, participants provided the scores of quality of experience, comfort, and presence. All questionnaires and methods followed the recommendations and guidelines from the literature. The experiment was conducted using a platform developed in collaboration with Alessandro Rodrigues, another student from PPGI. Currently, we are preparing an article to share the platform to the scientific community. The experiment counted with 63 participants in total and was collected 6,804 hating observations. Given technical problems that happened with Rift S, 2 devices was used in the experiment. To this presentation, we will show just 2 of the main results of our work, together with the insights emerging from the posterior analysis. Our analysis has mainly 2 targets: the SRC, where we test the impacts of the source content, and the PVS, where we test the impact of the edit versions of the videos. Since we had 2 groups of devices, we tested the validity of using together the data as a single group. For that, we performed a well-tested test that is adequate for unbalanced data. No statistically significant differences between the device groups was found in terms of presence. However, for comfort and quality of experience, we found statistical difference. Then we repeated multi-pairwise tests by grouping them by edit type and was able to verify that the statistical difference was related to only one condition, the gradual edit with 20 degrees per second in the case of comfort. In the case of quality of experience, the difference was also related to a single condition. As a conclusion, we combined the dataset with caution for preliminary analysis, with the remark that hidden factors associated with device can be presented in comfort and quality of experience results. Exploring the data, we can observe from histograms that the distribution of comfort scores is non-normal and follows an apparent inverse Poisson distribution. In the case of presence and quality of experience, non-normality was confirmed with a Shapiro test, and we can observe that the scores has very similar trend across all video contents. Confirm if variables measured was well differentiated by participants while rating the videos. We compared the correlation between different responses, comfort, presence, and quality of experience using three types of correlations. Following correlation, we applied a significance test with a result expressed in terms of p-values. All correlations converged to the following results. First, scores given to comfort and presence are statistically independent. Second, quality of experience and presence have high positive relation, while quality of experience and comfort have negligible or low positive relation. Because quality of experience was related to other responses, from now on, we will focus our analysis only on presence and comfort. Considering the cross-relationship of content and edit type, we observed from comfort mean opinion scores that there was no clear degradation of comfort in any case since it was always superior of score 4. Furthermore, we note that an expected comfort decrease depending on the rotation speed, while for all cases the instant or snapcut edit had at least one gradual edit with very similar result. When compared to comfort, presence has flatter mean scores across all edit types, showing a tendency that edit type did not matter so much for viewers' presence. We also note that the differences are more subtle than that of comfort. A clear degradation for presence scores was observed for dense content, where mean scores was below 4 for 3 edit type, especially for the instant edit. Considering our scene dynamic classification on fixed, steady, and dynamic, for comfort we observed the same trends as before. An almost uniform presence mean opinion score was observed, while a more evident decay of comfort for the steady and dynamic content was observed. When comparing both comfort and presence scores across content, corroborating with other works, we found a negative trend between comfort and presence. To test whether SRC has a significant effect over the responses, two hypothesis testing procedures was conducted, one for content and other for scene dynamic. Since the assumption of normality and homogeneity of the variance was not confirmed by Levine's test, we performed a non-parametric Kruskal-Wallis test for both presence and comfort. It was found a statistically significant effect of content on comfort given a chi-square distribution equal 39.7 and 5 degrees of freedom, as well as a significant effect on presence with p-square equals 42 and 5 degrees of freedom, confirming, as expected, that content plays an important role explaining the part of the variance of subjective scoring of comfort and presence. To examine better where reside the difference found, we performed a post hoc Wilcoxon rank sum test with continuity correction. As a result, for both comfort and presence, content had a significant impact over for 8 of 15 conditions tested. Overall, content is important to explain both comfort and presence scores. However, other important factors are present since it does not explain the difference of seven cases. Considering the scene dynamic classification and the interclass significance comparison, for comfort, all interclass comparisons had no significant difference. For presence, just one interclass comparison had no significant difference. So, we could not confirm that this classification is relevant for presence. However, scene dynamic categorization fits the classified content in terms of comfort. So it is an important factor to account when measuring content impact on comfort. That alignment performance of the edit do not impact the subjective assessment of presence and comfort. Alignment performance also impacted evidentially the behavior right after the edit, specifically the head speed 1 second after the edit that was significantly reduced. Gradual edit showed superior capacity of head speed reduction, reaching a reduction of 80% than that of the instant edit. For the gradual version of alignment edit, the recommendation of our study for angular speed is 10 degrees per second, since it was acceptable in terms of comfort, while was able to reduce head speed in 14.9 degrees per second. This was the references of our study. Thank you for your attention. Now I am open to questions or comments.